We navigate our digital lives through a series of effortless taps and swipes, rarely considering the physics of the glass beneath our fingertips. While your brain registers the physical feedback of pushing against a hard surface, the sensors inside the phone are blind to the actual weight or pressure of your finger. Instead, the screen detects a change in its own environment, sensing the microscopic amounts of electricity naturally carried by the human body. The glass serves as a protective barrier for the true interface, a field of energy projected from a microscopic grid just beneath the surface. To see how this works, we have to look past the exterior and into the microscopic architecture sandwiched inside the display. This is a capacitive grid. It is a hidden matrix of intersecting lines that maintains a continuous, uninterrupted electrical charge. In its baseline state, this current flows evenly and predictably across every horizontal and vertical wire in the system. This constant charge functions as a delicate tripwire system, designed to monitor the screen for any external fluctuation in energy. Before you even make contact, the phone is actively projecting this net of energy, waiting in a state of perfect electrical balance. Because the human body is conductive, it naturally carries and moves small amounts of electricity from the surrounding environment. At the microsecond your conductive fingertip meets the protective glass, your skin absorbs a tiny portion of the screen's localized electrical charge. This contact breaks the grid's equilibrium, causing a sudden disturbance in the energy field at that exact point of contact. The wires immediately surrounding your finger register a localized drop in voltage. Every tap you make is a minute electrical theft that disrupts the balanced ecosystem. To make sense of this disruption, the phone must translate the physical loss of electricity into geometric data. The system's sensors measure the exact horizontal and vertical location of the voltage drop on the grid, pinpointing the X and Y coordinates. Having found the location, the system packages these spatial coordinates into a digital data signal. This process converts the chaotic physical interaction of a human touch into precise, measurable digital geography. This data signal is instantly transmitted from the screen's grid to the phone's internal processor. The processor receives the raw coordinates indicating exactly where the energy field was broken. It then compares those physical coordinates against the software interface currently being displayed on your screen. When the processor confirms that the coordinates of your touch match the location of a specific button or key, it executes the corresponding command. The processor maps these electrical gaps to the icons on your display, converting a localized drop in voltage into a deliberate action. This entire cycle, from grid equilibrium to physical disruption to command execution, completes in a fraction of a millisecond. Every message sent and photo swiped relies on the device repeating this process countless times throughout the day. Navigating a mobile interface requires your biology to physically interfere with the device's electrical balance. Every interaction with your phone is a physical manipulation of this grid, turning a simple touch into a precise disruption of an invisible electrical field.